is a quick video about soil water presented by Group 1 Bioinnovation students for SCIN 261. Enjoy!
For our target group, we focus on the high schooler around grade 6 to grade 12. And for our key messages, or is the points of our presentation, there are 5 of them. First is to decide the audience to understand what is soil water. The second one is the relation between the soil water potential and the soil water. The third one is about the SMT, or the soil moisture tension value. The fourth one is talk about how relation between the SMT and the plant growth. And the last one is the application of SMT, which you can see in many kinds of agricultural tools.
And now we're at Siri Lukashad Nature Learning Park, and this is the soil that contains water. Absolutely yes! Today we're going to talk about soil water. What is soil water? Soil water is the water in the soil. The abilities to absorb water in soil will depend on different types of soil and the free space in the soil particles.
How can free spaces in the soil be related to the water movement? The answer is about the pores, or the free spaces between the soil particles. The pores tend to be the controller of the water movement. So it means that the more spaces between the soil particle, the faster water can move. And in this case, we will indicate the VDO experiment that illustrates the differences between loam soil, clay, and sandy soil. And you can see that the sandy soil shows the most free space in the soil, so the water can move past through it faster than the clay. And moreover, we have another experiment about the water absorbance, and you can see from the result, which is the remain water, that loam soil is the best soil for water absorbance.
Before we get into more details, let's talk about the technical term that we use in this clip video. The first one is soil moisture potential. Soil moisture potential is the measure of energy status of soil water, which show the abilities of plant that work to extract the water from the soil. The next one is negative pressure. The negative pressure is the pressure that develops in silence as water is released from the leaf.
Another part that related to the soil water is the soil water potential. This is the potential per unit of mass, volume, or weight of the soil water. This picture shows the relation between the pressure and the water thickness of the soil particle. You can see that the closer to the soil particle gets, the more negative the water potential. And the soil water potential can be calculated by this formula. The first one represents the total potential. Gravimetric potential is the force of the gravity pulling on the water. So with our osmotic potential, due to the difference in salt concentration, I call the semi-permeable membrane such as the plant root. Metric potential is the force presses on the water by the soil metric to soil water. We can call it the tension. And the last one is the pressure due to the external force.
But how can water be connected to the soil? Adhesion force will connect the water particle and soil particle in the free space. This force will bond between the positive side of the water and the negative side of the soil particle. If we talk about the soil, the typically found thing that will be present under the ground in the plant root. The root can absorb water from the soil by using negative pressure. Negative root pressure is the tension or suction force that the root uses to pull water out of the soil. When the water molecule flow out of the stomata, the negative pressure will occur within the xylem due to the water being drawn out of the column through the vascular system. This process will draw the water from the root to the top of the plant. It is measured in unit of Pascal or bar. The value typically doesn't over -1 megapascal or -10 bar.
The factors affect to the negative pressure are the structure of roots and the radius of the capillaries in plant roots. The smaller the radius is,
the higher the tension will be increased. On the other hand, if the capillary is large, the tension will be decreased. Rather than reducing negative pressure to absorb water from soil, the soil also has resistance to store water, which is called SMT or soil moisture tension. The SMT value represents the strength of soil or the pressure that is required to pull water out of soil. SMT is measured in pressure unit.
Factor of SMT. Soil type. Different types of soil have varying water holding capacity and water retention properties. Sandy soil typically have lower water retention, while clay soil have higher tension due to their ability to retain water. Depth of root zone. The depth at which plant roots are active can affect SMT. Deeper root can access water at lower tension, whereas shallow root plants may require a higher SMT for water uptake. Vegetation and plant type. Different plant species have varying water requirements and tolerance level for soil moisture tension. Some plants can thrive in drier conditions with higher SMT, while others require consistently moist soil with lower tension. Irrigation practice. The frequency and amount of irrigation applied to the soil can directly impact SMT. Proper irrigation management can help maintain the desired tension levels for specific crops. Organic matter content. Soil organic matter improves water retention and can reduce SMT by increasing the soil's ability to hold moisture. Soil compaction. Compacted soil have reduced porosity, which can affect water movement and increase SMT. Compaction can be caused by heavy machinery, foot traffic, or other factors. Soil salinity. Saline soil can have higher SMT values because the presence of salts in the soil can reduce water availability to plants.
How can SMT values affect the growing rate of plants? The answer is SMT values affect the water absorbance in roots, and this will affect the growing rate of plants. The higher SMT values, the drier the soil will be, and this will lead to the limited diffusion of nutrients in soil. As a result, ta-da! The plants will be malnourished and the stem will get stunted. Furthermore, SMT values will also affect the photosynthesis process due to the significance of water. High SMT values will indicate insufficient soil moisture conditions, and this will decrease the photosynthesis rate and also with the production of plants.
SMT can be adapted from many equipments and tools. We have two examples for SMT application. The first one, tensiometer, is the meter that used to measure soil moisture in units of negative pressure, known as tension. This is useful in agriculture. The second one is a gypsum block. It is a sensor that measures soil moisture from its electrical resistance. The advantage of using gypsum block method are no soil sample is required. More frequent reading for the same field and the same location can be taken, and it saves time.
To sum, soil water is the water that is retained in the soil. It can show the water absorption capacity of each type of soil. The more porous the soil is, the faster the water can move through. There are many forces that take part in soil water, such as adhesion force, but negative pressure takes an important part to allow plant roots to absorb the water. The value of negative pressure depends on the space between soil particles and the radius of the roots. Soil water potential is also used for measuring the energy status and reflects the work that plants need to do to extract the water from soil. It's also related to SMT value,
V is the value that indicates the moisture and water retention of the soil. High SMT value represents the insufficiency of soil moisture and affects as inhibition of growth rate and decreased photosynthesis rate of plants. On the other hand, if the SMT value is too low, it will result in the growth of bacteria in the soil and destroy plant growth competently. So, factors that affect the SMT value must be accepted into account, such as the type of plant, the depth of the soil, or even the salinity of soil, that will allow us to know and determine the appropriate SMT value for each type of plant. SMT value can be applied for several appliances, such as tension measure and gypsum block. Knowing soil water could grant the understanding of agriculture, which type of soil is appropriate with this plant, and which conditions of soil are suitable for them. This aspect of knowledge may help you understand the relationship between soil, water, and plants better.
And this is our special part. Research in physics, in biology and medicine textbook for a question that related to our content. The question we came up with was, if a section of cross-grain soil is adjacent to finer-grained soil in the same material, water will shift from the cross-grain to the finer-grained soil. Explain the reason for this. Our group thought that according to the mentioned information about surface tension of soil, more surface means more tension. A finer soil normally has a smaller particle. Therefore, in the same amount of soil, the finer one will have more surface. Our discussion ended up with finer soil had more surface tension. That's why water shifts to the higher tension.
That's all for this clip video.
Hope you enjoy in our content.
Or get some new information.
This is QR code if you need more detailed document 5.
And if you want some more details, please scan it.
Thank you for listening and attention for this topic, the soil water.